Hello everyone, and welcome to this exciting guide on how to make your own sodium chloride salt crystal at home. So my name is Ahmad Izzuddin Darwisha bin Idris, and today I will be walking you through the fascinating process of crystal growth. Let's dive in. Okay, here is the materials layout. So the material is only simple because we only need the sodium chloride salt, water, small cap or shallow dish, glass container, stick, cotton rope or string, and then filter. Step 1. Preparing the solution. So to begin our crystal growing process, the first step is to prepare a saturated salt solution. Here is how you do it. So start by heating some water in a pot or pan. It's important to heat the water until it is hot but not boiling. So aim for just below boiling temperature, which is 100 degrees Celsius. Boiling the water could lead to rapid evaporation, which may interfere with achieving a uniform crystal growth pattern. So once the water is sufficiently hot, slowly add your salt to the pot. You can use table salt, sea salt, or any type of sodium chloride salt available. As you add the salt, continuously stir the solution with a spoon, stirring until you notice that no more salt can dissolve in the water. At this point, you will see undissolved salt grains starting to settle at the bottom of the pot. This indicates that the solution is saturated. Step 2. Options for crystal growth. Once you have prepared your saturated salt solution, using a strainer or a clean filter, pour the saturated salt solution through it. This process removes any undissolved salt particles or impurities that might interfere with the crystal formation. So here you have two options you can choose from. First option, pour a small amount of the filtered salt solution into a shallow cap or dish. And second option, pour a few filtered salt solution into a glass or plastic container. Step 3. Setting up for crystal growth. Let's explore these options in detail. So the first option is very simple and requires minimal steps, which take a shallow cap or dish and pour a small amount of your salt solution into it. That's it. No additional materials are needed as the water in the solution evaporates over time and small crystals will start forming on the surface or edges of the dish. This method is quick, easy and great for observing how crystals begin to grow. The second option involves a bit more preparation, but it is perfect if you want to grow larger, more defined crystal. So here what you need to do: take a piece of cotton rope or string and tie it securely to a stick or similar support. Second, suspend the string in your salt solution, making sure it does not touch the side of or bottom of the container, and it is important to ensure the crystal grow along the string. And finally, set it aside in a safe spot and let time work its magic. This process usually takes a few weeks. Step 4. Observing the crystals. So for the first option, as you can see here, on the first day you will notice tiny and shiny spots beginning to form on the surface of the shallow cap or along the edge of the dish. These are the initial signs of crystallization. And the second day, the crystal will have fully formed in the shallow cap. If you choose option 2, the crystal growth process is slower but more dramatic. After about a week, you will start seeing small cubic crystals forming along the suspended string. Unfortunately, since I didn't have enough time to let the crystals grow fully using this method, I will be showing you the result through this picture instead. These visuals demonstrate how the string setup begins to crystallize over time. So by the 4th to 6th weeks, the crystals on the string will have grown significantly larger and more defined. So before we continue, I'd like to acknowledge that the video and imagery for the string growth method are credited to the Literary May on YouTube channel. It's a great resource for anyone interested in hands-on science experiments on that YouTube channel. Step 5. Extracting and preserving the crystals. So once your crystals have fully grown, the final step is to carefully extract them and ensure they are preserved properly. To To extract the crystals, start by gently removing them from the shallow cap or stream. If you are working with a smaller delicate crystal groomed in your cap, you can use tweezers or a small spoon to carefully lift them out. And to preserve your crystals, store them in an airtight container. You can add a few silica gel packets to the container to absorb any excess moisture. Now we have done with the crystal growth procedure, so let's dive into the physics concept behind the structure of the sodium chloride crystal. So, lattice type, the sodium chloride crystal has a FCC, which is a phase center cubic lattice structure. In this arrangement, the sodium ions and the chloride ions alternate in a repeating three-dimensional pattern. The FCC lattice is efficient in space usage, meaning the ions are packed as densely as possible, and this arrangement also minimizes repulsion between light charged ions and maximizes the attractive force between the oppositely charged ions, which is why the sodium chloride structure is so stable. In sodium chloride, the basis consists of two ions, which is a sodium cation and chloride anion. These two ions together form the simplest repeating unit of the structure, which creates the larger crystal when repeated throughout the lattice. And the lattice constant is the length, which is each length of one side of the cubic unit cell, which in the case of sodium chloride is approximately 5.64 angstroms. The coordination number of sodium chloride is 6. This means that each sodium ion is surrounded by 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions. In a pure FCC lattice, like in metals, the coordination number is 12 because each atom is surrounded by 12 nearest neighbors. However, in sodium chloride, the lattice is made up of two different ions, which is sodium and chloride ion, arranged alternately. The coordination number is reduced to 6 because each ion is only surrounded by ions of the opposite charge. So next, we go to the bonding in sodium chloride crystal. So the type of bonding, as we know, is the ionic bond, which is sodium chloride form an ionic bond due to the transfer of one electron from a sodium atom to a chlorine atom. So sodium being a metal loses one electron, becoming a positively charged sodium ion, while chlorine gains this electron from a negatively charged chloride ion. So these oppositely charged ions are held together by electrostatic force of attraction, which forming a strong bond. Thank you for your attention and for joining this presentation. I hope it provided you with valuable insight into the fascinating properties and structure of sodium chloride crystals. If you have any questions or would like to discuss further, feel free to ask and comment below.